Supplementary essential variables explained. An attempt at a short video. Once again, I'm going to try and keep it short, but sometimes it doesn't happen. I'm going to try not to get off into the weeds too far, but I think I did on this one. My apologies if it runs over, but anyways, my name is Gary A. Pace. I'm a PE CWI, May 2019. Key terms and definitions. Essential variable, a parameter that when changed outside its permitted range requires requalification. Is any condition changed that could affect the quality and integrity of a weld deposit and would necessitate requalification. Supplementary essential variables are conditions in which a change will affect the toughness properties of the joint, heat affected zone, or base material. The supplementary essential variable becomes an essential variable when welding procedure qualification requires impact testing. Toughness testing. Special consideration is given when toughness testing is required by other sections of the code. The toughness supplementary essential variables do not apply unless referenced by the construction codes. When toughness testing is required for welding procedure specification qualification by the construction code, the supplementary essential variables become additional essential variables, and a change in these variables requires requalification of the procedure specification. So ASME Section 9 isn't going to tell you when you need to use supplementary essential variables. That's all going to be in the construction codes. And when we're talking about toughness, we're talking about the ability of a material to absorb kinetic energy, to absorb abuse, to take punishment, to get hit by a hammer, big rocks, whatever analogy you want to use to get it straight in your mind what toughness testing is. So ASME Section 9 isn't going to call it out, but the construction codes are going to call out when toughness testing is required, and this is going to kick the supplementary essential variables into play, and they will then become essential variables. And that's all they do, is they just become another essential variable. Okay, so here's a slice from ASME Section 9 that lists the welding variables for procedure specifications, shielded metal arc welding. So you can see the blue, the yellow, and the red where I've outlined essential, supplementary essential, and non-essential. So essential variables, as I said before, are for everything. You have to address those on both the PQR and the WPS. Regardless, those need to be addressed. Non-essential variables, those just get addressed on the WPS. And supplementary essential variables are only utilized when impact testing is required by a construction code. And you just go down there and you look at all the X's, and if there's an X next to one of the variables, then you need to address it appropriately. If it changes from your original qualification, you need to go back and address it and requalify the procedure. Do another PQR that covers the supplementary essential variables. List of welding codes. So when we're talking about welding codes and construction codes for the ASME, American Society of Mechanical Engineers, they've got some code sections like Section 2 or Section 9. Section 9 doesn't tell you how to build anything. Section 9 just tells you how to qualify welders, welding procedures, PQRs, and whatnot. And then you have other parts of the codes like ASME Boiler and Pressure Vessel Section 1, which is the rules for construction of power boilers, or B31.1 and B31.3, power piping, process piping. There's a whole list of these that are construction codes. So when you're building something, let's say we're working to ASME B31.1, which is power piping, we would just end up working to that code, and we're following all the rules of that. And let's say at some point it tells us that we need to have impact testing on our material. And I don't know if 31.1 requires impact testing or not on anything. Don't know. but I'm just using it as an example. So let's say that code says, hey, you need to do impact testing on this material. Our supplementary essential variables now become essential variables. But these are examples of construction codes. Section 9 is a document reference for qualification of material joining processes by various construction codes, such as Section 1, 3, 4, 8, 12, etc. These particular construction codes apply to specific types of fabrication and may impose additional requirements or exemptions to Section 9 qualifications. So these are the ones that are the driving force on whether or not you're going to need supplementary essential variables. These are the ones that are going to explain whether impact strength is required, whether you need to do impact testing on the material. This is the driving force. These are the ones that are going to tell you whether you need to have impact testing or not. And these are what we talk about when we say construction codes. They are the rules for construction. Section 9 has no rules for construction of anything. Iron, when it's in its body-centered cubic phase, the body-centered cubic arrangement, it goes through a ductile to brittle transition temperature. Carbon steels are very susceptible to this. You'll see this as you go north, somewhere like Edmonton, Alberta. You'd have materials that would act in a very different manner at a cold temperature than they would at a higher temperature. Something like you'd see in Phoenix in the summer, that same piece of steel is going to act way different at minus 40 in Siberia or Canada or Alaska. So that's what we're talking about. And this is what we call for when we talk about impact testing. You can see on this slide, we're talking about the ductile brittle transition temperature. So with this one, body-centered cubic materials like iron and steel that are in a body-centered cubic crystal structure at about 0 degrees centigrade, we'll call it 30 degrees, 32 degrees Fahrenheit, they'll start losing the amount of impact energy that material can absorb. So this is why when you when you make a component, let's say for a warm climate like South Texas or Arizona, and then you have the same part made of the same type of steel and you send it up to Alberta, it'll function great in the summer months, but then when it's 40 below and that body-centered cubic material is operating in the brittle behavior region, which is this far left-hand side of this picture, it's going to shatter like glass. You can see that it loses a significant amount of impact strength as the material cools. So this is just something to think about, and this is why when we don't use carbon steel for cryogenic situations. We use stainless steels and aluminums and other materials that don't have this ductile to brittle transition temperature in them. QG 105.3 Supplementary Essential Variables. Supplementary essential variables are conditions in which a change will affect the toughness properties of the joint, heat-affected zone, or base material. Supplementary essential variables become additional essential variables in situations where procedure qualifications require toughness testing. When procedure qualification does not require the additional toughness testing, supplementary essential variables are not applicable. So when we're talking supplementary essential variables and toughness testing, it gets back to our material. And for example, body-centered cubic materials like your basic garden variety carbon steels, like an A36, will go through a ductile to brittle transition temperature. Above a certain temperature, the material will fail an impact test in a ductile manner. It's more of a tearing. It doesn't really break. I don't know if tearing is the right word, but it doesn't break. It doesn't shatter like glass. Once it cools down below that temperature, it goes into a brittle phase and it basically shatters like glass. So that's what we're talking about. This is the driving force between that forces supplementary essential variables into becoming essential variables. Supplementary essential variables, some examples. These are some for shielded metal arc welding from table QW 253. Group numbers, diameter greater than 1/4 of an inch, and heat input. So these are for shielded metal arc welding. Each different welding process, and it depends on the code too. Different codes are going to have different supplementary essential variables. And within ASME Section IX, each welding process is going to have different supplementary essential variables. So the ones that are relevant for gas tungsten arc welding might not be for submerged arc welding and gas tungsten arc welding. So you just got to look it up and read. P numbers and group numbers. So within ASME Section 9, all the base materials that the code recognizes for construction of pressure vessels are broken down into P numbers. And the P numbers are groupings of stuff that's pretty close to being the same. So that you can qualify a weld procedure with anything within that P number, and you get to use all the other materials listed in that P number until impact testing requirements come by. So once impact testing requirements are invoked by a construction code, you can only qualify materials within a group. So here we have, I've got some examples listed. So I've got SA 106A, which would be a group 1. It's a P1 group 1. So if my welding procedure originally was qualified and I qualified it with A106 base material, and I wanted to weld a SA 299 grade B, which is a P1 group 3, I can't if impact testing is required. If there's no impact testing required, I could make that weld and it's not an issue. But the minute impact testing requirements are invoked by the construction code or by the engineer or some specification, our P numbers are then broken up into group numbers, which is, it kind of tightens up that classification and says, okay, this stuff, when we were doing construction without impact testing, group 1 and group 2 and group 3, it's all close enough. We don't need to worry about it. But once impact testing requirements are invoked, we need to follow up and make sure that we're following the rules, because these mechanical properties and metallurgical properties of the different groupings are different enough that the code recognizes them as such. So they can't be mixed interchangeably when we have impact testing requirements. So we need to keep track of our group numbers, and that's what they're talking about when they say if we change group numbers. We would move from one material within the P1 group to another grouping of material within the P1 materials. Here's another example of a supplementary essential variable. If we change the diameter of the filler metal while we're stick welding, so if we go from, let's say here on the lower left-hand corner, we've got E7018, which is an F4 material. Let's say we qualify the procedure and it's 1/8 inch diameter filler material. Well, let's say we decide we're going to go to the same filler material, E7018 F4, but 5/16 of an inch, which is greater than 1/4 of an inch. Well, according to the code, you're putting in enough heat that it's going to change the base metal to HAZ and the weld metal in a metallurgical manner that it's going to react to mechanical testing. It's going to have different mechanical properties than what we had originally done with the 7018 at an 1/8 inch diameter. So here's another example. If you change the diameter of the filler material from what you originally qualified to anything over 1/4 of an inch. As long as we stay under that 1/4 of an inch, we can do what we need to do. But you cross the 1/4 of an inch diameter filler material, we got to requalify. It's a different PQR at that point. So when you have a change in heat input, you need to requalify the weld procedure also. So heat input is 60 times amps times volts divided by 1000 times the travel speed in inches per minute. This will give you kilojoules per inch. So heat input is very important in regards to impact testing because the amount of heat that you put into the material is going to have a significant impact on your impact strength. I didn't mean to use impact twice, but it's going to have a big influence on the impact properties of the material that you've just welded. So heat input is a biggie. So if you're going to change, if there's a increase in heat input, then you need to address it and requalify another PQR that covers the heat input for what you're doing. Another example would be change in position, QW 405.2. A change from any position to the vertical position uphill progression. Vertical uphill progression, e.g. 3G, 5G, and 6G qualifies for all positions. In uphill progression, a change from stringer bead to weave bead. This variable does not apply when a WPS is qualified with post-weld heat treat above the upper transformation temperature or when an austenitic material is solid solution annealed after welding. But for the most part, this is telling us that if we're running in our, let's say we qualify our weld procedure, Section 9, in a flat position, and we want to run it vertical uphill in the 3G position, we're going to have to requalify the weld procedure and keep track of the heat input, because there's a drastic amount of heat, more heat being thrown into the material in the vertical up position than there is in a flat or a horizontal position. And here it's even telling us that if we switch from a there is no drastic format change to the WPS format in regards to impact testing, and when you flip over to adding supplementary essential variables, all you're doing is tweaking a couple of different things. So for the size of the filler material, you just list the size of the material. There's going to be some changes on the PQR, but you're just going to record those and address them on the PQR. And you're going to address your supplementary essential variables on the welding procedure specification. There shouldn't be that much change. It's not like it's a drastic change where you've got to, gut half your weld procedure and start over and it's a completely different format. It's the same format, but you're just tweaking a couple of different things, a couple of editorial changes, and you're using a new PQR to back up your WPS and to support your WPS. Sharpie impact testing. The tests are conducted by mounting the samples as shown in Figure 8 and allowing a pendulum of a known weight to fall from a set height. The maximum energy developed by the hammer is 240 foot-pounds in the Sharpie test. By properly calibrating the machine, the energy absorbed by the specimen may be measured from the upward swing of the pendulum after it has fractured the material specimen as shown in Figure 9. The greater the amount of energy absorbed by the specimen, the smaller the upward swing of the pendulum will be and the tougher the material is. Sharpie V-notch test. You can see how you take your specimen after it's cooled to whatever temperature, and you put it in the anvil, and you can see where the striking edge of the pendulum hits on the opposite side of the specimen from the notch that you've machined into the test specimen. And you have the starting position of the pendulum, the striking edge. It comes down, it whacks that test specimen, and in whacking that test specimen, the test specimen absorbs an amount of kinetic energy, impact energy from that hammer. So then the pendulum and the hammer only go up a certain distance. Well, you measure that distance, and that tells you how much impact energy the test specimen was able to absorb. And you do this on multiple test specimens, not just one, because I keep preaching this, but it's because the data that you receive from just one test specimen is probably, there's a good chance that it's out of the ballpark. So if you based your decisions on one test specimen, you wouldn't be getting a good answer. You might be, but there's a reason why they do these things in multiples of 3 or more. Different materials are going to have different fracture toughness results, and they're going to be held to different acceptance criteria. But here's some examples of some materials and their fracture toughness strengths, I guess it would be. You know, the test temperatures that we were using it out, and then how many foot-pounds of energy that it'll absorb. Questions, comments, suggestions? Hopefully we didn't get too far off into the weeds in regards to my explanation of supplementary essential variables. You got any questions? You know how to find me. My name's Gary A. Pace. I'm a PE CWI out of Katy, Texas. Everybody take care. Talk to you later. GP out.